Hey guys, today we're going to work on some factoring and solving quadratics. We're going to start with, on page 90, number 63. On page 90 it says solve the quadratic equation x squared minus 3x minus 28 equals 0. When you solve a quadratic equation, the first step is you want to get everything on one side of the equal sign and have 0 on the other. This one's done for us. Then you want to try to either factor, or if it doesn't factor, try the quadratic formula. Or if you really want to, you can complete the square, but I would stick to the quadratic formula. This does factor. First of all, we attempt to factor out a GCF. There's nothing in common with these three terms. So we're going to move on and try to find two numbers that multiply to negative 28 and add up to negative 3. That would be negative 7 and 4. If you're not good at factoring, take a moment, grab your calculator, and type in the y equals, let me clear all this out. If you type into your calculator in the y equals part, that last number, the multiplication number, negative 28 divided by x, and look at your table, this gives you all the numbers, all the possible combinations that multiply to negative 28. It's a good idea to give yourself a visual, so then you can just scroll around and find which numbers, like these, add up to negative 3. So after you factor, you simply set each factor equal to 0 and solve 7 and negative 4. And what you really have just found is where this quadratic, which is a fancy math word for a parabola, crosses the x-axis. So just to give you kind of a rough picture, this is a positive x squared, so it's a U-shaped parabola. It's going to cross the x-axis at negative 4 and 7. So at negative 4, 0, and 7, 0, it crosses the x-axis. These are called the roots, or x-intercepts, or solutions. Let's try number 66. Number 66 says we have 2x squared minus 3x minus 5 equals 0. This does not factor. Well, it might, but we have this number out in front of the x squared. So I would avoid trying to factor this. I would use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So a is in front of the x squared. A is 2. B is in front of the x, so it's negative 3. And c is negative 5. So we're going to take these three numbers and plug them in. So it'll say negative negative 3 plus or minus radical negative 3 squared minus 4 times 2 times negative 5. This is over 2 times 2. So you have 3 plus or minus radical 9. I wouldn't touch this minus sign. 4 times 2 times negative 5 is negative 40. When you subtract the negative, it's like adding, and then the denominator is going to be a 4. So we have 3 plus or minus radical 49 over 4, which is 3 plus or minus 7 over 4. Now this is two solutions like our other one. 3 plus 7 over 4 and 3 minus 7 over 4. So this is 10 over 4, which is 2.5, and negative 4 over 4, which is negative 1. So those are our two solutions in this case. And then finally, let's do on page 142, number 64. Which says, use the quadratic formula to solve x squared minus 14x equals negative 2. In this case, we first have to add 2 to both sides. We cannot solve a quadratic equation unless everything's on one side of the equal sign. Next, we try to factor out a GCF. There's nothing in common with those three terms. So we're going to use the quadratic formula. A is 1, B is negative 14, and C is 2. So we'll plug into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get negative 14 plus or minus radical negative 14 squared minus 4 times 1 times 2 all over 2 times 1. So we get 14 plus or minus 196 minus 8 over 2. So 14 plus or minus radical 188 over 2. Now this isn't as nice as the last question because radical 188 does not break down. So we try to find a perfect square that divides evenly into 188. The perfect squares are numbers like 1, 4, 9, 16, 25, 36. I would just try using your calculator and see 188 divided by 36. No. 188 divided by 49. No. Just try numbers. What about 4? Okay, 4 works, and that left us with a 47. So what we're going to do is rewrite this as 14 plus or minus radical 4 times radical 47 over 2. Radical 4 is a nice number. That's why we chose it. So it's 14 plus or minus 2 radical 47 over 2. And then finally, kind of make a pretzel. If these three numbers on the outside of the radical have something in common, you factor it out like a 2. 7, 1, and 1. 7 plus or minus 1 radical 47 over 1. So I know these numbers are weird, but basically this parabola crosses the x-axis at 7 minus radical 47, comma 0, and 7 plus radical 47, comma 0. Actually, this would be, both of these would be positive. But give the problem a try and let me know if you have questions.